right, today we are going to complete our weather study guide. If I'm moving too fast, please feel free to pause the video and catch up as we work through this together. Or you can just watch this video as a good review tool before your check-in for weather. All right, so weather moves from west to east. It tells us that in its name. Weather moves from west to east. There are two systems that move the weather from west to east. They are the jet stream and the prevailing westerlies. Prevailing westerlies is a global wind pattern. We have not quite given this the attention that it needs, but it is another weather pattern, a global wind pattern, that moves our weather from west to east. Remember that winds are named by the direction in which they flow from. So since these winds flow from the west, they are the prevailing westerlies. So those, along with the jet stream, move our weather from west to east. And this is a good reminder that you should probably put at the top of your brain dump when you begin your check-in. All right, so now let's talk about the weather tools. This tool measures the amount of precipitation. It is the rain gauge. Rain is a form of precipitation, so it has precipitation in its name. This measures temperature, and it is the thermometer. It literally says it in its name. The thermo, which is the thermal energy that it measures. That word meter means to measure. So this measures the thermal energy. It's right there in its name. Describe the direction from which the wind is blowing. The weather tool that describes the direction, it's not going to have the word meter in it because it's not taking a measurement. This one is describing, and that is the wind vane. And it's going to give us a reading such as north, south, east, or west, or a direction in between. This measures the amount of humidity in the atmosphere. So again, since we're finding a measurement, it's going to have that word meter in it. And this is actually the hygrometer. Anytime you see hygro or hydro, that means water. So again, this measures the amount of water vapor or humidity in the atmosphere. Next, we've got a measurement of the wind speed. Which tool measures the wind speed? That would be our anemometer. Again, it has that meter in its name because it's finding a measurement. The last one, and Ms. Hernandez's favorite, this measures air pressure or the weight of the air, and that is our barometer. All right, we're done with the first section. Now we're going to open it up. And we're going to look here at the section about seasons. Seasons are caused by look at these axes. Does that look like a straight line going up and down? No, it is a tilted axis. So seasons are caused by the tilt of the earth on its axis. So the tilt of the earth on its axis is what causes seasons. And we're going to look here and we're going to label the seasons. So we can see here that the northern hemisphere is facing away from the sun. It's tilted away from the sun. So it's going to get a small amount of direct sunlight, which means that the northern hemisphere has winter here. So that means that the southern hemisphere is now leaning toward the sun. So that means that the southern hemisphere is going to have summer. Just like north and south are opposites of one another, winter and summer are also opposites. So knowing which season we are having and just finding the opposite of that would be how we would find the season for the southern hemisphere. So we're going to follow the arrows on around. So after winter, it gets a little bit warmer. We've got a little bit more direct sunlight here. So after winter, we have spring. Okay, and then after spring, we are now tilted toward the sun, and we are experiencing summer. And then lastly, now we're receiving a little bit less direct sunlight because we're kind of like tilted sideways toward the sun. or sideways facing the sun. So again, we're not tilted toward the sun. We're now tilted sideways, just facing the sun. So that's going to give us fall. And then we're going to go back through with the southern hemisphere. So the opposite of spring is fall. And the opposite of summer would be winter. And then the opposite of fall is spring. All right. So now the blank receives the most direct sunlight each year. So when we're looking at the globe, what part of the globe experiences the most direct sunlight each year? And that would be the equator. It receives the most direct sunlight, which is why it's our tropical area and it's our hottest area. So as we move closer to the equator, it does get warmer. Now, knowing that the equator is the hottest area, that would make the poles the coolest area because they receive the least direct sunlight each year. So the poles. We've already answered this in the diagram, but here it is again. So that's probably meaning it's important. When it is summer in the northern hemisphere, it is blank in the southern hemisphere. So summer in the north, it's going to be the opposite in the south, because the southern hemisphere is opposite of the northern hemisphere. The opposite of summer is winter. When it is summer in the northern hemisphere, it is winter in the southern hemisphere. Hopefully I said that right. All right, weather versus climate. One of these is weather, one of these is climate. Blank is the current state of the atmosphere and minute by minute changes. And then this one says blank is the weather over a long period of time. Weather is the current state and the minute by minute changes. And climate is the weather over a long period of time. If that's what you said, give yourself a pat on the back. All right. So now let's move on over to the right-hand side before we open up to Ms. Hernandez's favorite part of the brochure because it's got the barometer in it. This is a current high in the atmosphere that separates warm and cold air masses. It's like a tube or tunnel of air, and the jet stream flows from west to east. Just gave us our answer. Yes, the jet stream is an air current that is high in the air. Where do jets fly? In the air. Therefore, the jet stream is in the air. Just think of its name. All right, and we're going to draw an example of the jet stream across North America. And it says that it is like a tube or tunnel of air. So I always like to draw my little curly cues all the way around to make it look like a tunnel. And then it says that it separates warm and cold air masses. So we're going to go ahead and do that. And we're going to remember that the warm air, goes to the south of the jet stream because you've got your warm air from the equator working its way up. And you've got the cool or cold air from the poles working its way down. And that jet stream serves as a boundary between those two air masses. All right. Next up is a blank ocean current in the Atlantic Ocean, and it flows from the south of Florida up the East Coast and toward Europe. And that, my friends, would be the Gulf Stream, which is a warm ocean current in the Atlantic Ocean. Okay. And then our last two global patterns that you need to know for your check-in is El Nino, which is Spanish for the boy, and La Niña, which is Spanish for the girl. And El Nino is a climate pattern representing an unusually warming of the Pacific Ocean. And as that Pacific Ocean warms up, it leads to more evaporation, more condensation, and more precipitation, which is going to move those clouds and precipitation from west to east with our weather systems. So we're going to have more rainstorms. So we're going to think of a hot, sweaty boy when we think of El Nino. El Nino means the boy already. And the Pacific Ocean is hotter than usual, and it's going to bring that moist, wet weather. So we're going to think of a hot, sweaty boy when we're thinking of El Nino. And then the opposite for La Nina, it is an unusual cooling of the Pacific Ocean, and it's going to bring cool, dry weather as our weather systems move from the west to the east. So we're going to think of Queen Elsa there. All right. Then we're going to finish up this brochure here with the last couple sections, which is warm front. And this is where our circles point in the direction the weather is moving. And it may bring steady precipitation, light rain or snow. And when we think of warm front, we're going to think of the stratus clouds as it sneaks up and slides over that cold air mass, okay? So it's moving slow and sneaky. So I'm going to go ahead and trace over this with the red, because on our weather maps, it's a red curved line with the little red bumpies. The cold front, we've got triangles that point in the direction that the weather is moving as it barrels through and cuts through like a knife. It may bring heavy thunderstorms, so we're going to think of those cumulonimbus clouds, rain, or even snow. And again, we're going to think of our cumulonimbus clouds. Okay? Trace over that with our blue. Stationary front, it does not move. It stays there. Does not move for an extended period or a long period of time, and it may bring steady rain or snow. Remember, stationary front has a little bit of both. You've got your cold front moving this way on this example, and the stationary front and the warm front is moving this direction. The circles are still pointing in the direction in which they're going. So this area is going to receive some cool air once they push past one another, and this side is going to receive some warm air once they finally pass by one another. And then our last example is going to be the occluded front. The occluded front. And when we, this is when a cold front, cold front catches up to a warm front and overtakes it. So it runs over it. And it's usually going to bring light precipitation. Okay, and it's purple. It's got that mixed air with it. And eventually these fronts usually kind of die out once that air really mixes good. Last but not least, we've got the barometer, Miss Hernandez's favorite. We have a circle split in half here. We're going to have our rain on the left, and you can kind of see that in the image there. And sunshine on the right on the high side. And our 29.5 in the middle there. I've got a reminder here that as the temperature goes up, the pressure goes down to remind us that low pressure is usually, not always, but it's usually associated with warmer air. And then our high pressure, as the temperature goes down, the pressure goes up. So we usually associate high pressure with cooler air. And for high pressure, let's see, let's do it down here. High pressure is heavy air. The weight of the air is heavy, and it brings happy weather. We can remember that because we put the little smile in the sunshine. And then on the left side, which is our lower air pressures, anything lower than 29.5 will be light air. Low pressure brings light air, which results in lousy weather. There are a few things that we associate with the low pressure. First is all of these fronts, because all of these fronts produce precipitation. So when we think of low pressure, we're going to think of all the weather fronts. And we're also going to think of 2 rainmaker clouds. So we've got all the fronts create low pressure. And then we've got clouds that also create that low pressure. And they are our big, tall cumulonimbus cloud that stacks high into the sky and creates the thunderstorms, which could result in tornadoes or very severe weather. Okay, so we have cum, u, low, nimbus, and we also have stratus. Stratus clouds also bring weather, or bring low pressure precipitation, that lousy weather that we associate with low pressure. And then there's 2 clouds that we associate with high pressure, and they are the cirrus clouds and the cumulus clouds, which is another happy little cloud like cotton. All right, so if you study the study guide, it literally has everything that you can need to know for your weather check-in. And if you have any questions, please feel free to ask.